Hello everyone. Welcome back to Dr. Lou's VCE Science channel. Today, let's learn together about the 2023 chemistry examination. We will focus on questions related to electrochemistry. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Yes, any cells produce heat because they cannot 100% transform chemical energy into electrical energy. Some energy is released as heat energy. So, A is correct. Both cells can have inert or active electrodes. So, B is eliminated. Both cells can have porous electrodes because this increases the reaction surface area. So, C is eliminated. Electrons flow through an external circuit instead of an internal electrolyte. So, D is eliminated. Identify the specific features of a secondary cell. Secondary cells can be discharged or recharged. When it is discharged, a secondary cell is a galvanic cell. When it is recharged, a secondary cell is an electrolytic cell. So, only D is correct. Green gases are carbon dioxide and water. Both petrol and hydrogen are oxidized in fuel cells by oxygen gas to produce water. So, they produce gases and A is correct. Both petrol and hydrogen fuel cells produce heat because their chemical energy is not 100% transformed into electrical energy. So, B is eliminated. They are different fuels, so, energy transformation is different, and C is eliminated. The reactions of all fuel cells are exothermic, no exception. So, D is eliminated. The amount of carbon atoms in one methane is the same as that of methanol, so they produce the same amount of carbon dioxide. Also, they contain the amount of hydrogen atoms, so they produce the same amount of water. So, both methane and methanol produce the same amount of greenhouse gas when they are completely burnt in fuel cells. So, C and D are eliminated. However, one methane loses 8 electrons and one methanol 6 electrons when they are oxidized. So, one electron produces a different amount of energy between methane and methanol. So, A is eliminated, and B is correct. The cathode receives electrons from the external circuit. The negative charge will be accumulated in the cathode and positive charge anode. To balance the surplus negative charge in the cathode, the positive ion must flow from the anode to the cathode. So, A is correct. The voltage is dependent on the different potential between conjugated redox pairs. So, B is eliminated. In acidic electrolytes, oxygens gain electrons and combine with hydrogen ions to synthesize water. This reduction occurs in the cathode or positive electrodes. Carbon atoms lose electrons and combine with the oxygen of water to form carbon dioxide. This oxidation occurs in the anode or negative electrodes. So, C is eliminated. All reactants must have direct contact with the relevant electrodes. So, D is eliminated. When the cell is discharging, it is a galvanic cell. During discharge, Pb loses its electrons at anode, and lead dioxide gains these electrons at cathodes because lead dioxide's EMF is higher than Pb's. In this galvanic cell, hydrogen ions react with lead dioxide at the cathode. So, B and D are eliminated. When the cell is recharging, it is an electrolytic cell. During recharge, electrons are pumped out from lead sulfate at the anode by electrical power, and into lead sulfate at the cathode. Hydrogen sulfate ions are produced at both electrodes and not reactant. So, A is eliminated, and C is correct. Both thiosulfate ion and sulfite ion can be oxidized to provide electrons. After thiosulfate ions lose electrons, they are converted to sulfite ions. Sulfite ions will be further oxidized. So, the sulfite ions are final reductants. So, minus 0.94 is selected as the lower EMF, and 1.56 is the higher EMF. The different EMF between them is 2.50 V. So, C and D are eliminated. In both half cells, the oxidizing and reducing agents are ions in solution, and an inert electrode should be selected, and Pt is an inert metal. If Mn metal is used as an electrode, it will be involved in reactions. So, A is eliminated and B is correct. There is no iron in solution, and iron is the strongest reductant here. So, iron is not produced, and A is eliminated. All oxidizing and reducing agents are mixed, so no electrical voltage is produced, and B is eliminated. Hydrogen peroxide is the both strongest oxidizing and reducing agents, so they react with each other. On the other hand, iron ions catalyze this reaction. So, the concentration of hydrogen peroxide will decrease. The decomposition of hydrogen peroxide is exothermic, so the temperature of the contents increases, and D is eliminated. This is a secondary cell. During discharge, its chemical energy is transformed into electrical energy. During discharge, the oxidation number of ions decreases from +3 to +2. So, iron 3 ions gain electrons and are oxidizing agents. The half equation is asked during recharge. Recharge is the reverse reaction of discharge. Here, the number of carbon, oxygen, and sulfur is balanced on both sides, but hydrogen isn't. So, we should balance the hydrogen on both sides. First, add 2 hydrogen ions to balance the hydrogen atoms on both sides, because of the acidic solution. Second, add 2 electrons to balance the charge on both sides. To recharge this cell, electrons should be pumped into this electrode. So, they should be connected to the negative electrode of the power supply. Explain how the polarity of the electrodes is established during recharge. I think about how to connect the polarity of the cell to the power supply during recharge. Recharge is the reverse discharge. During recharge, its negative electrode becomes a cathode containing C14H8O8S2. This cathode should be connected to the negative terminal of the power supply, which pumps electrons into it. During recharge, its positive electrode becomes an anode containing Fe2+. This anode should be connected to the positive terminal of the power supply, which pumps electrons out from it. So, to recharge these cells, the negative electrode of this cell is connected to the negative terminal of the power supply, and the positive electrode of this cell is also connected to the positive terminal of the power supply. But its anode during discharge is also an anode during recharge, and its cathode is also a cathode because anodes always lose electrons and cathodes gain electrons. When we disuse electrolysis cells, anode and cathode are better words than negative and positive electrodes. Generally, the copper is purified by electrolysis cells. Impurified coppers contain zinc, lead, and gold. To explain how electrolysis can purify copper, students should state a definition of electrolysis and what happens to the O, Zn, and Pb. Also, they are asked to refer to the electrochemical series. This question will be awarded 5 marks. When the impure copper is electrolyzed, an electric current passes through the electrolyte and circuit to push a non-spontaneous redox reaction. During electrolysis, the electrical energy is transformed into chemical energy. The impure copper is placed on an anode connected to the positive terminal of the power supply. The electrons are pumped out from impure copper, and copper, zinc, and lead are oxidized to ions. However, gold is not reduced to ions because gold ions have the highest SEP and gold is the weakest reductant. So, the gold simply falls from the anode as anode mud. When the ions of copper, zinc, and lead attain at cathode, copper ions are the strongest oxidant because copper ions have the highest September, so the copper ions are reduced but zinc and lead ions are not. Finally, the pure copper is deposited on the cathode and other metals or anode mud are left in solution. To complete all processes, the voltage of electrolysis is key. This voltage is enough to pump out electrons from copper, zinc, and lead, but avoid too high so that gold is oxidized to ions. Explain how to apply a Faraday constant in Faraday's first law. This question is not involved in any actual calculation. First, how to calculate the coulomb of charge passing through electrolysis cells. Second, how to calculate the moles of electrons by the Faraday constant. Third, how to calculate the moles of bromine produced through the ratio of the mole of bromine and electrons. There are 8 multiple-choice questions worth 1 point each, 8 total marks. There are also 2 short answer questions worth a total of 15 marks in this section covering electrochemistry. The overall score for this section is 23 points. With a total possible score of 120 points, the percentage for this section is 19.2% of the total score. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lu's VCE Chemistry channel.